So my next guest today is Mike Bixeman. He is President CEO of Magnalytix. Welcome, Mike. Nice to see you.
Thanks for having me, Trevor.
Yeah. It's been a while since we've spoken, but Magnalytix has been around a few years now. You're essentially into SIR testing. What have been the latest developments out of the Magnalytix stable?
Well, there's been quite a few developments. SIR testing has come a long way. It used to be that SIR testing was done on open comb test boards. The soldering companies used SIR testing to qualify all their soldering materials. But where Magnalytix has made a significant contribution to industry is designing these test boards with components that are more representative of the challenging areas that trap flux residue or process residues. And so, throughout that whole process, we have been able to design different tests, and we really focus a lot on testing services. We do a significant amount of testing services for people all over the world. It's a significant area that we not only get to deliver great value to the client, but we always get to learn.
Yeah.
We get to see emerging trends. We get to look at different materials, soldering materials, where are the challenges, secondary processes. It's just opens up a wealth of knowledge.
Which helps you to develop the product quicker and better, I suppose.
Absolutely. Yeah. Whenever you see where problems occur, and you know where problems occur, it also shows you where there's opportunities for solving those problems.
Absolutely.
And if you can solve problems, why wouldn't people want to work with you?
Well, I know they get you excited, that's for sure. But you're absolutely right. But let's dial back to the bit with the coupons, the test coupons. Are they always customized to what the client is using, or do you have some standard ones?
We have standard ones that people traditionally use for the assembly type environment. They're top side, bottom side. They cover all soldering processes that are used to build a circuit card. Failures are typically component specific, so we select components that typically trap residue. The bulk of the failures on a lot of assembly processes come from selective soldering and rework. So you want to include those in your test card design.
Yeah.
So those are the kind of standard test cards that people commonly use to develop their objective evidence to J Standard 001, and we provide the test cards. We build the dummy components, and so we move forward. And so that innovative test card has been one of the key areas that I think makes us a little different.
Right. And are these test cards typically built on FR4?
Many of them are, but we have worked to also design glass SIR test boards.
Okay.
What we do is we use a copper metallic polymer that can be screen printed onto the glass. It can be coal-fired, and we can build an SIR test board that we can populate FR4 type components onto it. What's nice about it is that whenever you have leakage currents or you have drift or you're not fully cleaning, you can see the residue, and you can also see the dendritic growth pattern. So it gives you that visual aspect, which is really a nice area to really understand the process and the material stack up.
Right. So what other challenges are you finding coming up in the industry? I mean, we're moving towards more power devices. You've got all these issues coming on with the servers and data farms and places like that, with huge thermal excursions, where they're using liquid cooling and all sorts of things. What are you finding are your biggest challenges at the moment?
Well, in all of these areas, we have had opportunities from clients that have wanted us to build custom test boards that can help them understand those applications, which opens up a problem that we get to learn from. And for example, on the data centers where they build these large ASIC processing chips, for AI,
Yeah.
they have thousands of BGA underneath these. Some of them are exceeding 10,000, so they're very large components, and they generate a lot of heat.
Yes.
So as they generate heat, now how do they cool them, and what's a more efficient way to do that? So one of the ways that the industry's going is liquid cooling, or they basically put the electronics in immersion cooling baths. So during that whole process, if those baths have any type of contamination,
Yeah.
it doesn't have to be flux contamination. It can be contamination from materials or other sources. There's
the plastics and things like that sort of leach
Yep.
into the water.
Yeah, they leach
Into
into
the-
the water, and they can cause goo and even ECM formation underneath the immersion. So that whole area requires, constant filtration of those systems. And so, part of what we do today is we do SIR testing under immersion.
Right.
So, and we build test cards that are designed for that space. We build heating units into the test card so we can simulate the actual heat
Okay.
background, so that you have a realistic scenario to what they're facing, and you can understand not only the selection of the right materials, but how important is the cleanliness of that tank and keeping it to that
Yes.
cleanliness level.
Yes. Because once, presumably with the higher amount of contamination getting into the tank, then the less effective it is at cooling and keeping the temperature.
Well, what
or
it's
cleaning.
even that is true, but what happens is that these contamination, when you think about these large components, these contaminations, can get trapped underneath those components.
Yeah.
And as they get trapped underneath the component, you can actually cause a different form. It's almost like creep corrosion. And whenever that occurs, these are expensive,
I know. Chips.
chips.
Yeah.
And you don't want them to fail. So
Yeah.
so it's an area that is another area of testing that we can do to help clients understand, qualify their process, and to also understand where those weak points are and what they need to do
Minimize
in
the
their
risk.
process
Yeah.
to mitigate it.
Yeah, absolutely. Well, it's a hugely exciting area, to be honest, at the moment.
Well, the one thing that as problems beget opportunities.
Yeah.
We're in the great thing about this whole electronic space is that we're always reaching for more, faster, better. And when you do that, miniaturization crops in, all of these
Heats and
areas
thermals, yeah.
come about, and every one of those areas creates something that has to be addressed.
Yes.
If you're in an environment where you understand and you see and you work with in that type of application, it opens up an avenue to say, can we solve that problem? If
Right.
we can, it brings forward growth opportunities.
Well, one area that they're looking at to use to try and maybe mitigate some of the heat is by bringing in more photonics into the packaging. That's probably going outside of your scope, I know, but I guess you've got to make sure that these connections are very clean, so that you get the best conduction of the light.
Yeah.
It doesn't. Obviously, the light doesn't create the heat that you get with a copper conductor.
It's an interesting thought, because we have not worked with photonics as of yet, but that's just another avenue that we would be very open to,
Yeah.
to understanding, to learning from those applications. What does it really mean?
Yes.
And where's the failure mechanism come from? And across that failure mechanism, is there something that we do through our test methodologies, the different instruments that we design that can be there to help our clients understand what those risks are and how to, again, mitigate.
Mitigate it. Yeah. Well, as you say, we never stop learning.
No, that's the beautiful thing about this whole space is, it's always about continuous learning. When we first started Kaizen Corporation, the whole name came, the background came, a search for, continuous improvement.
Continuous improvement,
And,
that's right.
we, being in an environment to where, things do emerge, it's, to me, it doesn't get any better than that.
I mean, but, continuous improvement really should be at the heart of any business, no matter whether you're in electronics or not. I mean, you can't stand still. You've got to keep reinventing yourself. But I mean, it's lovely that we have an industry where we keep challenging ourselves and learning of new technologies.
Well, the other thing that's really interesting about our whole industry is that none of us has the solutions to all these problems.
Correct.
But just think about AI, just for an example.
Mm.
If you use it smartly,
Yeah.
it can give you a lot of insights.
Absolutely.
But there are a lot of people that are subject matter experts in different areas. And the other piece of an area that, it's been my background, is collaborating with other people
Yep.
to help solve problems
Yep.
so that we all win at the end of the day. And, that whole process of, reaching out, working with others to figure these things out is another piece of the magic.
It's another piece of it, Mike. But I mean, I think the thing is, you also have to be able to work out ways to capture that information and digitize it, so that you can get up there for the next generation and to take it forward. And I think the other thing is, you have subject matter experts, as you say, but they're not there all the time.
That's
the more
true.
you can digitize it, the better.
And one of the key themes that we hear more and more is we're all getting older.
Yeah.
Many people are retiring.
Yeah.
So how do you bring that knowledge forward to a younger group of engineers? The one thing that I think is that, technologies are well documented. It doesn't take people long to learn those.
Mm.
But what it does do is that if people become immersed into an area that drives their economic engine,
Yes.
it drives learning.
Yes.
And, as it drives learning, it is a natural effect that it actually takes care of itself. But with new tools that give you more insight at a faster rate, makes research easier,
Right.
so there's just a lot of good things that happen. It's just all a matter of framing it in the right way.
Well, exactly, and that's where Magnalytix came from.
Yeah.
Magnalytix was born out of a need to be able to measure and capture that information and digitize it.
Well, and in part of Magnalytix' opportunity was the ability to work with other people to help solve a problem. I think about Mark McMean and
Yep.
Mark's energy to do this and being able to work with him and that's how Magnalytix came about. But
Yep.
it's about having an open mindset,
Yes.
and looking at things and saying, okay, we may not understand it today, but we all know how to learn.
Yeah.
And,
And working
information is so readily available I think you could do almost anything if you put your mind to it.
Put your mind to it, and you conceptualize it correctly and get the information. Yeah, there's loads of information out there. Absolutely.
So anyway, that's kind of what we try to do.
Yep.
We're not perfect, I
Yep.
can tell you that, but we love to serve the customer, and we like to try to follow the opportunities where they may take us.
There you go. Well, I hope you have many more opportunities ahead of you, Mike, and
Yeah.
it's always great to catch up.
Yep.
So thank you for coming in.
I appreciate you giving me that opportunity, Trevor, and thank you again for allowing us to be a part of this process.
No, my pleasure. Okay, take care.
For micro dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in life.